Hi Calc, this will be the last part of the lecture today, so congratulations, you're making it here to the last video. This is example 3, and again on exam 3 I will give you the derivatives just like I'm doing here. So let's go through the process one more time. So when I look at the original function, I have some initial thoughts. The first thought is this has some particular characteristics that I need to note. Like for instance, it has a domain restriction, right? X cannot equal to 4 because otherwise it's undefined. So I'm going to take note that it's undefined because the graph has a vertical asymptote at x equals to 4. That's why there is a domain restriction. I'm also going to note that since the degree of the numerator is exactly 1 higher than the degree of the denominator, that it has what we would call a slant asymptote. And I'm going to need to figure out where that slant asymptote is. So I can do that now. So remember, if the degree of the numerator is exactly 1 higher than the degree of the denominator, that is what creates the slant asymptote. You find the slant asymptote by long division, or you're welcome to do synthetic as long as the divisor is linear. If the divisor is not linear, then you cannot use synthetic division. You have to then go back to long division. So I'll just do long division, but you're welcome to do either. So the slant asymptote will be the quotient. So x goes into x squared 1 time. I'll change the sign with the red pen. So that's x squared minus 4x, but long division is opposite sign, so this becomes negative, this becomes positive. Just try to remember whenever you do division, I'll just remind you really quick, it's always implied subtraction. You introduce the negative, just like I introduced the negative here. You do that. All right, that goes negative 2x plus 12. Now I do it again. X has to go into that, so that's going to be negative 2. So that makes negative 2x plus 8, but now I have to opposite the sign. So that becomes positive. This becomes negative. So this is a 4. So it's x minus 2 plus 4 over x minus 4. Now what happens as you go to infinity, this part goes to infinity, but this part, the limit of this part goes to 0. So that's why this part doesn't play a role in the end behavior, because this collapses to 0. So what you're looking for is this. This is the slant asymptote. So the slant asymptote is the quotient. It's always the quotient. So I'm just going to write that y equals to x minus 2. Y equals to x minus 2. All right, let me see what other characteristics from the original that we didn't have before that we should find. All right, we should find the y-intercept here. If you let all the x's be 0, that goes to 0, that goes to 0, that goes to 0, you have 12 divided by negative 4, so that's negative 3. So that point is 0, negative 3. Do we have an x-intercept? Can this equal to 0? 3, 4, 2, 6, 1, and 12. No, no, there is no x-intercept here. X-intercept, none. So what I'll try to do on test 3 is prompt you to find certain things. I do realize learning online, some people may like it, some people this might be a bit more challenging. So I will prompt you on items to find for test 3 so you don't have to worry about whether you're getting everything that you need to find. So I'll prompt you on the information for this. Okay, let's move down to the first derivative. Actually, I think graphing's pretty cool. It's sort of interesting to see what these functions look like, and to have the skill set to actually draw it is quite a sophisticated thing to be able to do. Let's go ahead and find the critical number. So if you set the numerator equal to 0, you're going to get x's 2 and 6. If you set the denominator equal to 0, you get 4, but 4 is actually the domain restriction, so you don't want to put them in both categories. So I'm not going to include 4. If on the test you happen to include 4, you know, if you happen to put 4 here, I'm not going to mark it wrong, but it technically should be in one or the other category, not both. Same thing here, the critical point. Some people will put 4, but really you don't want to do that because, again, that is the domain restriction. So technically you actually want to say that there's none. But the big caveat here is that the domain restriction does go on the number line. So, you know, worst case scenario, you put it here, just make sure it gets on here. So we have 2, 4, and 6 on this one. Again, 4 is a domain restriction, just don't make sure you don't use it. So this is a critical number, this is a critical number, this is a domain restriction. I'm going to plug in some values. I'm going to see if there's something here that I can ignore. I can do this one because this is squared. This is always going to be positive. And again, I just be mindful of the time because the video cuts me off. All right, so when I plug 1 into the top, 1 minus 2 is negative, 1 minus 6 is negative over a positive. So overall, that's positive. That means we're going up. When I plug in a 3, that's positive, that's negative. Positive times a negative, that's positive always. So this is negative, this guy is going down. Okay, when I plug in a 5, that's positive, that's negative. Positive times a negative, the bottom's always positive. That's overall negative. Okay, when I plug in a 7, positive, positive, and that's always positive. Positive, 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 overall positive. Okay, great. Now let's go in and find any max and min. So at this critical number, on the left I go up, on the right I go down. So this right here is a max. At 2 something, we've got to figure out the actual coordinate on the graph where that happens. So you have to go to the original for that. So you actually have to plug in 2 into here. Oh, my brain already is calculating it. Let me write it so you can see it. Okay, so what are we getting here? 4 minus 12 plus 12 over negative 2, which is going to be 4 over negative 2, which is negative 2. So 2 negative 2 is the first one. You cannot, this is a domain restriction, so I'm not going to look to the left or right of it. This is a critical number. To the left it's decreasing, to the right it's increasing, so it's going down and then up. This is a minimum at 6 something. So again, you need to plug that into the original because we're drawing this picture here. That's what we're drawing. So f of 6, so 6 squared minus 6 times 6 plus 12 over 6 minus 2, 36 minus 36 plus 12 over 4, or 12 over 4, which is 3. Let me just make sure I got that right. 6 minus 36 minus 36 plus 12 over 6 minus 2 is 4, 12 over... Okay, great. Don't get worried that the minimum is higher than the maximum. That's fine because you have to remember that this is a vertical asymptote, so it's cutting this actually into 2 different graphs. It's one graph, but I mean it's in 2 parts kind of thing. Okay, let's move on to the second derivative. Now, there's no critical points, but remember you do have to put the domain restriction of 4 up. I'm going to put a big X there. That is a domain restriction, and the graph can change behavior around a domain restriction, so you always have to have it on the number line when you're testing it. The 8 is always going to be positive. It's the denominator that can change sign. So when I put in a 3, I'm going to have a positive over a negative, so overall this is negative. It's concave down. When I put in a 5, I'm going to have a positive over a positive. Oh, let me write that as second derivative, make sure I'm okay with that. Second derivative is greater than 0. That means this is concave up. Okay, so the left side's concave down, the right side's concave up. I'm not going to say this is an inflection point, because even though it changes concavity, remember, this is not a point in the middle. This is actually a vertical asymptote. It's splitting the graph here. Okay, let's graph this one. We are coming to the end of this. Woohoo! All right, let me just, you know, you always want to take into account what the size of your numbers are. So I'm just scanning. I got like a 4, a 6, a -3. Okay, my numbers aren't really that big in this one, so I'm just going to go with it. So I'll keep it sort of in my head what feels like a medium increment size. All right, so let's put this up. So we got, I'm going to start with the VA of 4. So we got a vertical asymptote at 4. If you remember even and odd, this would classify as odd. If you remember that, it classifies as odd because you just have one of these binomials, not two. So that means it's going to go in opposite directions, if you remember that rule. If you don't, that's okay, you'll figure it out. Okay, slant asymptote, you have to actually graph this guy. This is just, don't get confused by this guy. This is just a linear, I mean, people in algebra can graph this. It's a straight line, right? So don't like make it a bigger concept than it is, right? If x is 0, y is -2. If y equals to 0, then x is 2. You're just finding, you could just find the intercepts on that. And then you're going to graph the intercepts. So I'm going to graph 0, -2. I'm just graphing those points I just found. 2, 0. I just graphed these two coordinates, 0, -2, and 2, 0. It's right here. And that's all you need to draw a line. So now I can draw a line. I can draw a line with that. That's my slant asymptote, which is x -2. Okay, let's now figure out what else we got. Y-intercept at -3. Okay, this is 0, -3. This is my y-intercept. What else we got? No x. We got a max at 2, -2.